In this part, we will explain the method of rewriting the corrected and modified parameters for ArcSWAT resulting from the calibration procedure by the SWAT CUP program on parameters and discharge data resulting from the simulations in ArcSWAT in the manner described in the previous part, thus re-entering and typing these parameters in the ArcSWAT program and re-implementing them in ArcSWAT, thus obtaining a certified daily discharge data that simulates the reality of the study area and is used in processing calculations, analysis, and comparison later as follows. Whereas the result of calibration in the SWAT CUP program, as explained in the way that was conducted in the previous part, are present in this file entitled SWAT CUP C, where we open this file and in it the last of or best results obtained from the iteration E is in this path, and in it we open the file with the title SUFI2 out, and in it we open the file titled best-pir.txt, and in it we find the best parameters that we obtained from the calibration procedure in the SWAT CUP program. As we see, to get the results of calibration for iteration E or last iteration, we go to swatedit.exe and we make a right click on it, then open, and the results are written, and these results can be read by opening MGT file with the MGT extension, where we make right click on it, then we press open with, then we choose notepad, then OK. The result appear with the value of curve number CN2 is 76.5. As for parameters values, they are in GW file with the extension GW, where we make a right click on it, then we click on open with, then we choose notepad, then OK. The best value for parameters appear after the calibration, as we see. And now we rewriting or enter these parameters and curve number CN2 again in ArcSWAT for the study area project. thus obtaining a certified daily discharge data that simulates the reality according to this calibration. To do this, we go to the project file entitled SWAT project. This file is SWAT project, in which we open the project entitled SWAT project.mxd. We wait for the project to open inside ArcMap. The project opens inside ArcMap, and in it we go to the fifth menu from the ArcSWAT menu bar titled Edit SWAT Input, and in it we choose Subbasin Data. Then we go to SWAT Input Table, and from the drop down menu we choose Management.mgt. As we see, then we choose Subbasin 1 and land use AGRR, soils and slope. Then we press OK. In the results of the calibration for MGT file, we have curve number CN2, which is 76.5, where we click on edit values, and then we go to CN2 and we type 76.5, then we tick extend edit to selected HRUS, then we go to subbasin field and we choose the subbasins located in the upstream for the observed discharge data reading site at Dokan Dam, where the following subbasins include 1, 2, 3, 4, and 7. Then we go to land use field and we press all. Then in the soils field we press all. We go to land use field and we press all, and then in the soils field we press all, and then in the slope field we press all. Then we click on save edit. A message appears indicating that edits save it, then OK. We make sure to type the result in the rest of subbasins as we see. Then we return to the fifth menu entitled Edit SWAT Input, and in it we choose Subbasin Data. Then we go to SWAT Input Table, and from the drop-down menu we choose groundwater.gw. Then we choose Subbasin 1. land use, AGRR, soils and slope, then we press OK. Then we click on edit values. According to the calibration for the GW result, the value of GW-delay is 93. So we type 93 and alpha-BF is 0.75, so we type 0.75. As we see, we type 0.75 on alpha-BF and GW mine is 0.053, so we type 0.053 and GW-REVAP is the same value without change, and the rest of results have the same, so we keep the value unchanged, as we see. Then we tick extend edit to selected HRUS, then we go to subbasin field and we choose subbasin located in the upstream for the observed discharge data reading site at Dokan Dam, where the following subbasins include 1, 2, 3, 4 and 7. Then we go to land use field and we press all. Then in the soil field we press all, and then in the slope field we press all. Then we click on save edit. A message appears indicating that edit saved. Then OK. We make sure to type the results in the rest of subbasins, as we see. Then we have another parameter which can be reviewed in the next path, as we see. And it is SOL-AWC and its value is 0.516667, as we see. Where we return to the first menu entitled Edit SWAT Input, and in it we choose subbasin data. Then we go to SWAT Input Table, and from the drop down menu we select soils.sol. Then we choose subbasin 1, land use, IGRR, soils and slope. Then we press OK. Then we click on edit values. According to the result of calibration for SOL-AWC, the value of SOL-AWC is 0.51667, so we type 0.51667. Then we tick extend edit to selected HRUS. Then we go to the subbasins field and we choose the subbasins 1, 2, 3, 4 and 7. Then we press all, then all, then all. Then we click on save edit. A message appears indicating that edit saved. Then OK. We make sure to type the results in the rest of the subbasins as we see. Then we return to the fifth menu entitled Edit SWAT Input, and in it we choose Rewrite SWAT Input Files, and select input files to rewrite. Either we choose the files that contain the parameters that we have made the changes to it, and these files have the extension mgt, .gw and .sol. We click on select all, then we click on write files. A message appears indicating that done, then OK. And now we re-implement the project in ArcSWAT to obtain a new result according to new results of the parameters value resulting from the calibration in the SWAT CUP program, where we go to the sixth menu of the ArcSWAT menu bar entitled SWAT Simulation, and in it we click on Run SWAT. We have the period of simulation from 2000 to 2014 in SWAT.exe. We choose 64-bit release, and in the printout settings we choose daily. Then we press on Setup SWAT Run, then OK. Then we press on Run SWAT. Implementation starts and message appears indicating that SWAT runs successful, then OK. Then we go to the sixth menu entitled SWAT Simulation, and in it we choose Read SWAT Output. A window appears, and in it we tick all options. Then we press on Import Files to Database. We wait for the process to complete. Then we press OK. Then we click on Run SWAT Check. A window appears, and in it we press Examine Model Output. Then analyzing and reading the results start. The results appear in the simulation details as we see, and the rest of results in the following menus as we see. Now we are saving the simulation results for the daily discharge values after the calibration procedure, where we type the save name, which is daily C or daily calibrated. Then we click on Save Simulation. A message appears indicating that SWAT run successfully. Save it as daily C, then OK. The daily discharges values resulting from the simulation in ArcSWAT after performing the calibration, which are certified and simulate the reality of the study area and used in the treatment, calculations, analysis, and comparison later, are exist within the project file entitled SWAT project in the following path. inside the access file titled SWAT output.mdb and inside the RCH table, where we select values at the Dokan Dam location, where we make a left click on the subfield and we choose subbasin number 4, then OK. The daily discharges or flow-in at Dokan Dam site values appear, where we compare these daily discharges of or flow-in at Dokan Dam site resulting from the simulation in ArcSWAT after performing the calibration, after converting them to monthly discharges with the values of monthly observed discharge data to show the extent of the model's conformity to reality. Where we select and activate year, MON, area, and flow-in fields, and we make copy for them. Then we open Excel program and we make paste for these daily discharges. As we see, then we change the title of MON field to day, as we see. In order to convert these daily discharges to monthly discharges, we extract the average discharges per 30 days as follows, where we go to the next column and we set the cell at day 30 and we type equal. Then we click on function ffx and we choose if, and in the logical dash test field we go to the day field and choose the day. As we see, which is 30, then divide it by 30, then equal, then int. We open an arc and we go to the day field, then we choose the day, which is 30, then divide it by 30, then we close the arc. And in the value dash if dash true field we type average, we type average, and we open an arc. We choose the daily discharges for 30 day in the value dash if dash false field, and we type 0. Then OK, the result appears. Then we sweep down to show the rest of the results. As we see, then we activate the column or results field and we make copy for them. Then we open Excel program and we make a special paste for discharges value in values format. Then we go to the data menu, and in it we go to advanced filter and we tick unique record only, then OK. Then the monthly discharges value appear and we cancel the line containing false. Then we activate these values for monthly discharges and we make for them copy. And we open the Excel program again and we put names for the fields, which are month and year. As we see, and we go back and we make copy for the monthly discharges. Then we make a special paste for them in the values format in the month field. In year field, we type the year 2003 for the first 12 months, then the year 2004 for the second 12 months, and so on, as we see. In the next column, we type the sequence of these monthly discharges from 1 to 24. Then we compare these monthly discharges from 1 to 24 with the monthly observed discharge data values to make sure that the result of daily discharge values resulting from the simulation in ArcSWAT after performing the calibration match the values of the observed discharge data, where we make a copy for these values and we go to Excel file entitled SCH or SWAT Calibration Helper, and in it we note the week result of statistic parameters values before calibration, as we see. Then we go to flow data page and we add the discharges value on the SIM field after performing calibration via paste. Then we return to calculator page and in it we note the extent of the improvement in the values of statistic parameters in the calibration field and the extent of the match of the results obtained from the simulation in ArcSWAT after performing calibration with the observed discharge data values. Where by going to the Word file titled Statistic Parameters, we find that the performance rating of this hydrologic model is very good, whereas all statistic parameters are fall within these ranges, as we see. Thus, we have finished rewriting the calibrated parameters to ArcSWAT and a statement of the extent to which the model after the calibration conforms to reality.